Hi there, welcome to this video. My name's John. I provide maths tuition for A-level maths, A-level further maths, including 6-term examination papers and mathematics admissions tests. Very warm welcome to this video where we're going to take a look at something that causes a lot of difficulty for a lot of A-level students, and it's the modulus function. So we're going to take a look in a bit of detail at how to interpret the modulus function and how to deal with it. And I think a lot of the difficulties that people have with the modulus function essentially comes down to the fact that they don't know, in most cases, or they don't understand the definition of the modulus function. Okay, so if you don't understand the definition of the modulus function, you don't know what the modulus function is, or what it does, for example. A lot of people kind of have a vague idea about what the modulus function means. They've got something in mind that the modulus function makes everything positive, which is just hopelessly vague. To the point of uselessness. And yet, so many people try to understand the modulus function through such a vague definition. The modulus function makes certain things positive in certain ways, but to say that it makes everything positive is just so vague that it just leads people into error constantly. In the same way that people who try to remember that two negatives make a positive are constantly led into error, because whenever they see two negative signs in close enough proximity to each other, they'll just make a positive somewhere. So, for example, they might have something like -3 - 4, and they'll say, well, this is 7, because two negatives make a positive. So they've completely misunderstood what this means, right? They've misunderstood the limitations of this of the definition and how this particular rule works. So the top and bottom is, in mathematics, if you don't have a precise enough understanding of something, then you can forget about trying to use that thing to solve problems, or trying to solve problems which involve that thing. You may as well just pack up your bags and go home. So for example, in this case, the modulus function, if you don't have a precise enough understanding of the modulus function, forget it. Right, you're not going to be able to solve problems involving the modulus function because you don't even know what it is. So let's have a look at how the modulus function is defined. And yes, you do need to know this. You definitely need to know this definition. If you don't know this definition and you don't understand this definition well enough, then modulus function is meaningless to you. Okay. So what do we mean by the modulus function? So the modulus of x, okay, which we symbolize as x with two vertical lines surrounding it, the modulus of x is equal to it's equal to x if x is greater than or equal to 0, and it's equal to -x if x is less than 0. Okay, so it's a simple enough definition. It's just that you have to spend the time thinking about it and making sure that you understand what it's saying. So, for example, if we take the number 4, 4 is clearly greater than or equal to 0. So the modulus of 4, according to our definition, is just going to be equal to 4. Okay. And also the modulus of -5, for example. -5 is less than 0. So if we look at our definition, we're interested in this part of our definition. So the modulus of -5 is going to be equal to -5. But we know that -5 is equal to +5, +5. Okay. So yes, the modulus function does, in inverted commas, make things positive, right? So it's taken this negative number 5 and it's kind of sent it to its positive equivalent, let's say, or its positive counterpart. But 4, it just leaves the same. Or at least that's how we can interpret what's going on here. And there is still a transformation in both cases. It's just that appearance-wise, the transformation when applied to 4 leaves things unchanged in a sense. So once you you know this definition and you understand this definition, then you can really start to figure out what the modulus function is doing in different contexts. And this is where people really have a lot of difficulty, because there's a couple of transformations. So if we start with f of x, for example, function f of x, there's 2 main kind of basic transformations that we can derive from this involving the modulus function. There's the modulus of f of x, and there's f of the modulus of x. Now the first one, modulus of f of x, is the one that people are generally not too bad with. But the second one, f of the modulus of x, is where people just they've got no idea. In a lot of cases, they've just got absolutely no idea, and it really does come down to them just not having any real precise understanding of the modulus function. Now, don't get me wrong, there's also much more complicated transformations. So we could have, for example, we might have the transformation, the modulus of f of the modulus of x, for example. But this is, in a way, a composite of that it involves the first 2 transformations that I gave. So it's once you understand these basic transformations, modulus of f of x and f of the modulus of x, then you can start to build up much more complicated transformations. So it's really these 2 basic ones that you need as a starting point from which to build everything else up. So I'm not saying that you won't come across more complicated transformation. I'm not saying that every transformation that you get that involves the modulus will be one of the form modulus of f of x or f of the modulus of x. For example, I would expect that you might get at some point in your A-level course, whether it's normal maths or further maths, you might get something like this: y equals 3x minus the modulus of x, for example. Okay, this is not a transformation of the form modulus of f of x or f of the modulus of x. But if you understand these 2 basic transformations, then you can probably figure out what to do in this case, y equals 3x minus the modulus of x. We're not going to be looking specifically at that case in this video. We're going to be just looking at the 2 basic cases. So let's start with that first case. Right, so we've got the transformation f of x to modulus of f of x. So there's all sorts of ways that we can think about this. We can think about this in an algebraic sense. We can think about it in a geometric sense. We can think about this as a composite function. We can think about how we might describe this in words. And we kind of need to be familiar with all of these things as much as possible. And not only familiar with these things in kind of isolation, but how they relate to each other as well. Okay, so this does take time. This video, by the way, is not meant to be something that gives you a quick and easy way of understanding modulus function or something like that. It's not meant to try to bypass all of the understanding that you need to have. In fact, if anything, I'm encouraging you in this video to develop a certain level of understanding of the concept of the modulus function. One of the main warnings that I will give you is that if you don't understand thoroughly enough the concepts that you're dealing with in mathematics, then you're going to struggle, okay? And no amount of cheaty shortcut bullet point methods, no amount of acronyms or whatever is really going to help you. There's the only way to really be able to successfully attack mathematical problems is through understanding. And if you try to dodge the understanding, then if you're doing it willingly, then on your head be it, whatever the outcome is. Okay, so we might view this as a composite function, for instance. So if we've got g of x equals the modulus of x, then we can think about the modulus of f of x as g of f of x. Composite function g of f of x, which sometimes might be written as just g f x, for example. Sometimes there might not be the outer set of brackets around the f of x there. I tend to write g bracket f of x bracket rather than g f of x. So I tend to go for this version. That's just personal preference, but I'm ready to work with either. It doesn't make any difference to me. Okay, so let's have a think about what the modulus of f of x means in an algebraic sense, straight from the definition of modulus function. So this is going to be equal to f of x if f of x is greater than or equal to 0, and it's going to be equal to minus f of x if f of x is less than 0. Okay. So this is nothing more than the definition of the modulus of x, but just with the x replaced with f of x. Okay, so that's an algebraic understanding of this function, and in many ways this is a complete description of the function modulus of f of x. Okay. Now, I was just going to give a wordy kind of description of the transformation, but what I'm going to do actually first is I'm going to give a geometric interpretation of this, and then I'll give a wordy description of it. So what do I mean by a geometric interpretation? I mean a graph. Okay, so if I just draw kind of a generic f of x, what might it look like? Something like this, maybe. So I'm not saying that f of x always has to look, I mean, it kind of resembles a cubic, right? This is just meant to represent a generic graph. I've been sure to include bits that are above the x-axis and bits that are below the x-axis to really emphasize certain aspects of this transformation. Okay, so we can look at various parts of this graph. The bits that we're interested in are those bits that are on or above the x-axis, because these are the parts of f of x where f of x is greater than or equal to 0. But then on the other hand, we're also interested in those parts that are below the x-axis, because these are the parts of f of x where f of x is less than 0. Now this is just basic interpretation of graphs, which if you struggle with interpreting graphs and things like that, then it's something that you need to work on. It really is. There's no excuses. Once you get to A level, really, you've got to be able to understand graphs and relate graphical information that you can obtain through graphs to algebra and vice versa and things like that. If it's something that you struggle with, all I can say is you're going to have to work on it. Right, so what is my definition saying? So we've got the modulus of f of x is equal to f of x if f of x is greater than or equal to 0. So in other words, these bits of the graph that are above the x-axis remain unchanged. Right. What change though are these bits of the graph that are below the x-axis, because these correspond to parts of f of x where the value of f of x is less than 0. Well, my definition tells me that if I choose, let's say I choose this value here, so we've got x here, and then we've got f of x here. My definition tells me that modulus of f of x at this point here is going to effectively reflect the value of f of x in the x-axis. Right, so rather than getting this value here, which is f of x, I'll get minus f of x, which is going to be up here. Okay, so if I do that for all of these values that are below the x-axis, what am I going to get? Well, let me clear some space. Get rid of all of these bits. What I'm going to get then is, and I'll do it in a different colour, these bits are all going to stay the same. These bits above, on and above the x-axis. But the bits below the x-axis are going to be reflected in the x-axis. I'll do it the best that I can. So this red graph here is y equals the modulus of f of x. So what does this transformation do? The modulus of f of x. It takes the graph of f of x and it leaves all of the bits of f of x that are above the x-axis, on or above the x-axis, unchanged. The bits that are below the x-axis, it reflects in the x-axis. Okay, so I can write a wordy description now. So f of x to transformation f of x to modulus of f of x leaves unchanged any parts of the graph of f of x which are on or above the x-axis and reflects in the x-axis any parts of f of x which are below the x-axis. Okay. Sometimes it helps for you to be able to interpret symbols in just using plain English. Okay, and sometimes you might be asked to describe a transformation. So there we've got all different ways of understanding this transformation f of x to modulus of f of x as a composite function, in an algebraic sense straight from the definition of modulus function, in a geometrical sense, and we've got a wordy description in plain English of what this transformation represents. Now, what your job is to understand all of these interpretations and be able to relate them to each other, and this takes time and it takes work. And I'm not. There's nothing that I can say that is going to make this easy for you. I mean, I can make it easier, hopefully through the explanations that I'm giving, but I can't necessarily make it easy. So if you're looking for an easy way to learn all of this stuff, then, well, maybe you're expecting too much. Sometimes you do just have to put the hard work in. And if you don't want to, then don't. Okay, so we've got another transformation to have a look at, which is f of x to f of the modulus of x. Okay, again, we can think about this as a composite function. So if we've got g of x equals modulus of x, then in this case we've got f of modulus of x is equal to f of g of x. So before we had g of f of x, here we've got f of g of x. Or, as I would have a tendency to write it, f of g of x with the extra pair of brackets. Okay, so this is less straightforward to understand in a purely algebraic sense. Not necessarily impossible, but let's have a look. So f of the modulus of x is equal to f of x when x is greater than or equal to 0, and it equals f of minus x when x is less than 0. Okay, so again, let's think about this in a a graphical sense. X, f of x. And let's say we've got our generic function again, y equals f of x. What does our definition tell us? Well, here what we're interested in is when x is greater than or equal to 0 and when x is less than 0. In other words, we're interested in the origin and the positive x-axis and then the negative x-axis. So we're interested in the parts of the graph of f of x which correspond to to 0, x equals 0, and the positive x-axis on the one hand, and then on the other hand we've got the parts corresponding to the negative values of x over here. So what does my definition tell me of my definition of f of the modulus of x? It tells me that when x is greater than or equal to 0, f of the modulus of x just evaluates as if it was the same function as f of x. In other words, all this bit is left unchanged. Okay? So I don't need to do anything with that. I just leave it. Just leave it alone. But then, what about when x is less than 0? Well, this tells me that let's take a particular example, right? So let's say I want to find f of modulus of minus 5. This is going to be equal to the according to my definition, f of minus 5, which is equal to f of 5. Okay, so in other words, f of the modulus of minus 5. Let's call this h of minus 5, for example. H of minus 5 is just equal to f of 5. H of minus 7 will be equal to f of 7. H of minus 15 will be equal to f of 15. So if we're here at minus 5, let's say, f of the modulus of x, the function f of the modulus of x, will evaluate as if I were over here at 5. Right? So even though I'm here at minus 5, the function evaluates as if I were here. So it will give me the value of f that is here, right? So this is f of 5 here. That's the value that I'm going to get now when I'm here at minus 5. But the same applies to any negative value. Minus 3, or let's say minus 2. When I'm here, f of the modulus of x will evaluate as if I were here at 2. When I'm at minus 7, f of the modulus of x will evaluate as if I were here at 7. As if it were the function f, but evaluating at this value 7. So how do I interpret this? Let me just clear some space here. What it means is that all of this negative, effectively the negative part of this graph, or when I say the negative part, I mean that the part of the graph corresponding to negative values of x is scrapped. It goes. And what I end up with is a reflection of this part of the graph of f of x in the corresponding to positive values of x gets reflected in the y-axis. So I'll try and do this the best that I can, but it's not necessarily easy. Okay, so you get something, you kind of get that. Okay, you get the idea. And that's the graph now of f of the modulus of x. Right? So to get the graph of the f of the modulus of x, you scrap the the bit of the graph of f of x that corresponds to negative values of x, and just reflect the graph that corresponds to the positive values of x in the y-axis. So I mean, you could write that out as a worded description or whatever. I'll leave you to have a go at that. But again, it really is up to you to make sure that you understand, that you've thought about these concepts well enough and thoroughly enough so that you understand why these transformations work in the way that they do. Now, from these, of course, you could get much more complicated transformations. So it's not beyond the realms of possibility. Once you're familiar with these basic transformations, to deal with things like this, f of x equals, I don't know, 2 modulus of x plus x squared over 3 minus modulus of x, or something like this. Now, I mean, this is not a transformation of the form modulus of f of x or f of the modulus of x, but some combination, right? Some probably quite complicated combination of those transformations, along with potentially other transformations as well. But rest assured that once you're familiar with these basic transformations, modulus transformations, your stretchers, reflections, and translations, then something like this that's on the screen now is well within your capabilities of dealing with. You know, if you're asked to draw the graph of this thing, I'm not saying it would be something that you'd be able to do in 2 seconds flat. It would take some time to figure out, but you could do it. I'm not saying, by the way, that you will get something like this on your A-level exams, because you probably won't. So if you are only prepared to learn about stuff that you're gonna get on the exam, then okay, don't learn this. Don't bother with this, because you're not going to get it on your exam. But if you are interested, if you are actually interested in learning about mathematics, then have a go at something like this. See if you can draw the graph of this. See if you can figure out the details of what it's going to look like. And if you can, then you probably understand the basic modulus transformations well enough at that point. You've probably got a sufficient grasp of them. Okay, so hopefully you found something useful in this video. Please feel free to show your support for this channel by hitting the subscribe button and hitting the like button. I make these videos for free. I don't make any money from these videos, and I make them because I want to make them, first and foremost, and because I want to help people in the best way that I can. At the moment, I'm just making videos in the way that, in a style that I would have, that would have helped me back when I was doing A-level maths, or that I think would have been useful to me. But obviously, I'm helping myself there first and foremost. I'd really like to have some feedback from you guys. What do you want to see in these videos? How would you like me to help you better? Or to better help you, maybe I should say. How could I better help you? Is there something that I could be doing differently with my videos? What kind of things would you like me to be covering in the videos? I'm open to all of these kinds of comments. So please, if you've got any ideas, anything that you'd like to see me doing differently, doing better, leave some comments in the comments section. And I can't necessarily guarantee that I can make a video on everything to please everybody, but I'm open to new ideas, and I really want I'd really like some feedback. Also, like I say, show your support for this channel. If you do want me to continue making these videos, then I will do so, provided that I've got the support and the means for doing so. If the support's not there, then I'll move on to other things eventually. So, if there is anybody else that you think would benefit from these videos, please feel free to share these videos with them so that they can I can help them as well. I don't think there's anything else that I want to say on the modulus function. If you do have any comments, anything that you'd like to add, please leave the comments in the comments section. Even if you think that my videos are no good, or you think that they're not very good. If you think my videos are crap, I've got no problem with you saying I think your videos are crap, as long as you tell me why you think they're crap and what I could be doing better. Okay, constructive feedback is a good thing, even if it's a bit blunt. If it's not constructive feedback, then what's the point? Okay, so I'm going to leave it there. Thank you for watching this video. If you made it right to the end, then congratulations. And I will see you in the next video. Thanks a lot.